Hello, everybody. Thanks for joining today. And then hopefully you guys enjoyed the lunch. And then, it's super fast, and the lunch is not a long time. So I have only 30 minutes for the lunch today. And thanks for joining again. So I'm going to really talk about today Quarkus. I'm the Quarkus guy and from Red Hat. And then I'm going to a little bit more talking about the serverless and Java application today. So just about myself, and my name is Daniel. I'm from Red Hat as a developer advocate and technical marketing stuff, and also I am CNCF ambassador to evangelize a lot of cloud-native technology like Kubernetes and then OpenTelemetry and Prometheus, a bunch of a project. So my goal to bring more Java application into cloud, like Kubernetes, but also like Microsoft, Google, and Azure, and also Red Hat OpenShift as well. So here's my contact information in the thumbnail here, the Daniel030. You can find me Twitter, YouTube channel, and GitHub, and also LinkedIn as well. So by the way, so this is a whole the Quarkus theme, my slide, and then as you can see, maybe you can see my laptop here today. There are many stickers. I can bring some new Quarkus sticker here, and then here we actually created some Rockstar here. So the reason why we created the Rockstar sticker, so we make developer have some fun and then really happy. So. And after the session, I got a bunch of the Quarkus sticker here, and then just feel free to grab some whatever you need. So how many people actually have some experience to deploy your application into Kubernetes for? 1, 2, 3, 4, for real? So no one actually care about cloud? Everybody just doing your stuff on your local machine, like just a laptop or a desktop? Okay, I'm gonna accept the challenge today. So this is a Kubernetes, and then a lot of companies actually move forward to Kubernetes to deploy the application with the container technology, aka Docker. So the beauty of the Kubernetes, and then you don't need to worry about the application is down and up and down and scalability or service discovery. In the back then, I was a Spring developer, and then I have to figure it out myself to manage it, like a service discovery and the resiliency and then fault tolerance, etc. Like using Netflix OSS and then a bunch of the Spring integration ecosystem. And then once the Kubernetes came out in 2014, you don't need to worry about that kind of stuff. You just need to delegate your functionality to Kubernetes, and Kubernetes take care of all kind of stuff. However, the developer, including me, we had a support server habit. We still needed to do our own stuff. Okay, I don't care. And then I need to keep doing my stuff on my Spring Boot or any kind of Java application or .NET, Python, etc. But you cannot say my application cloud native application or Kubernetes native application because you just implement that kind of capability and functionality in your application side rather than using the cloud features. So this is one of the example. So the beauty of the Kubernetes is you scale out your application based on incoming network traffic. So when you coming more network traffic, the application automatically scale out. In order to that, what do you do as a developer standpoint? You need to make your Microsoft application like a small, fast, and independent, like loosely coupled and stateless, etc. Like just like 12 factors. And then the problem is here. So this is a Kubernetes. You have a multiple application like a order, service, or catalog, and then like a payment, and then all application running on Kubernetes like a container pod, and then you can say the horizontal pod autoscaler, which allows your application scale out based on network traffic, which is literally like a resource utilization, like a CPU memory. So if you set up your CPU utilization like a 70%, and once your CPU utilization exceeds 70%, Kubernetes, okay, now it's time to scale out based on your configuration, or 10 or 1,000, doesn't matter. As long as your cluster allows, and then it scale out like unlimited. So that is auto scaling. This is a really fantastic feature on the Kubernetes. However, but in reality, this is not the end. You have an external service, for example, like a Kafka cluster. So in the morning session, one of my friends, Mary, and over there, and then yeah, Kurt, and then they actually talked about really nice session around Apache Pulsar and Apache Kafka stuff. And then, so one of the example, the Apache Kafka is one of our external services. And then your application running on Kubernetes that actually needs to scale out based on that external service event streaming. But the Kafka is not only external services. So for example, Prometheus, metric data, and then like a cloud, like a AWS Cloud Watch and Azure Monitor. There are so many potential external services keep sending some kind of messaging to your application directly. And then Kubernetes actually don't care and then cannot control the external services. So this is some challenge happen and the problem just caused. So how do you do that? And then if you have any experience Kubernetes before, or you can talk to your SRE or platform engineer, maybe they're thinking about this solution. Okay, we can create the auto scaling infrastructure based on custom metrics. So we can create because Kubernetes provides like a custom resources definition, CRD, and then you can create the CR, customer resources. For example, here metric adapter. You can create the AWS CloudWatch metric adapter or Prometheus and the Azure monitor. But the problem is you cannot create the Kafka metric adapter directly. So that's why you need to liaison with the Prometheus. But the problem is here, you can only enable just one of the metric adapter at once in single namespace. However, here is the one namespace, like a project. And that project combine multiple microservices, like some module, like some catalog, order, cart, payment. And then each microservices maybe relies on different external services. For example, my payment services should be scaled out based on Azure monitor metrics. However, my order application scaled out based on Prometheus or Kafka cluster. They depends on different external services. That is a reality in the production. But with this auto scaling architecture, with using Kubernetes custom metrics, you cannot do that. So that's the one of the reasons why KEDA just designed and came out. So KEDA, literally the AKA Kubernetes event-driven auto scaling, is pretty much simple. You don't need to learn something new because the KEDA, once you install the Kubernetes cluster, it just keep watching your external services and then monitor that metrics and then decide when my application should be scaled up. So that is a KEDA. Once you deploy application existing cluster, you don't need to change anything because the KEDA supports standard Kubernetes resources like a deployment job and then like a custom resources, etc. So this is a KEDA just invented Red Hat and Microsoft and back then 2019, and then we donated to CNCF project, Cloud Native Computing Foundation, and then they adopted as the incubating project 2 years ago. And recently, in the January, 2 months ago, it released to 10. It's keep evolving the project. And then, so there are more than 61 built-in scalar, which allows you manage the external services and the event services, like Prometheus and Apache Pulsar and then Apache Kafka, RabbitMQ, and AWS services, etc. You can easily install, and even developer, you can easily install Helm chart or operator on your Kubernetes cluster. And then with that, we could redesign this auto scaling architecture. For example, we just got rid of the custom metric adapter, which is just so awkward. And then now we can have KEDA, and then KEDA, you cannot see that. And then the bottom line, you don't even see that HPA, the horizontal pod autoscaler anymore, because the KEDA let you create scaled object or scaled job. It allows to decide, and then your application scale up and down from 0, 1, 1 to 0. However, just one application is not good enough for high scalability. That's why KEDA, another capability, just ask the existing HPA, hey, I need to scale more than one, like a 10 or 1,000, even maybe 100,000. And then HPA, okay, I got you. And then HPA scale out after that. And then now you can enable multiple external services for multiple microservices, which is really cool. But though, keep in mind that KEDA is not serverless. It's just standard application. So this is a quick conceptual architecture, what KEDA looks like. And then you can see on the right-hand side, the scaled object here. And then here is the some workload, and then as you can see, here it's just the 0 to 1, 1 to 0. That's all right. KEDA uh, is working, and then KEDA also asked the HPA horizontal pod autoscaler needed to scale more than one, like 1,000, etc. It's pretty simple, and then you can only create some Kubernetes YAML file. I don't know. I know. The developer really hate the YAML file. Some people said YAML is pretty much similar to JSON format, but it's totally not. So I got a hard time to figure out the YAML stuff, back in 2014 when Kubernetes came out. So anyway, so this is the way you need to use YAML. And then one thing, you need to create the scaled object, for example. And then you can set it up the target reference, which is standard Kubernetes resources you're gonna keep stocking. So here is a deployment name. I'm gonna stocking this deployment, and then I'm gonna make a decide when it should be scaled, and also what is the coming resources from like a trigger. So here's the example Kafka. You can also using Prometheus and Amazon CloudWatch and anything external services here. So what about another question is serverless for auto scaling. So maybe some of them already heard about the Knative project. This is one of the component, not exactly component. It's one of the CNCF project as well. So Knative allows the developer manage existing microservices as just like a serverless, like Amazon Lambda. So when you deploy application to Amazon Lambda or Google Cloud Run and Azure Function, the application will be scaled down to 0 without any network traffic. For example, 30 seconds or even 1 minute. And after that, when you recall that application using like a RESTful API or click on some web page, things like that, it just automatically goes up. That's the behavior of serverless. And then, but you're gonna do that, the same functionality on top of the Kubernetes. How to do that? Why don't we just go to Amazon? Yeah, that's a good idea, but who's gonna be paid for that? And then your company, oh yeah, we already adopt a Kubernetes, and regardless of the community project or some vendors like a Red Hat OpenShift or the Amazon EKS or Azure AKS, whatever they pay for that already. And then the one thing your team leader or some executive leaders wants to you, just I want to deploy the application to serverless in somewhere Europe, because we just got a survey from analysts. More than 70% of your workload, the application don't need to up all the time, because most likely it's a seasonality. So some application just access some special period of time, not all the time, not 24/7. So what is the solution to save your money to maintain infrastructure as well as the application maintenance? You can adopt the serverless. And then what kind of platform is perfect for serverless? And then, oh, we already have a Kubernetes. And then we don't want to pay more money for Amazon, Microsoft, and Google, even Red Hat. And then, so how do I do that? Hey, this is a new project, Knative, to solve that problem. And then, but there's many challenges to use Knative, because Knative, you need to rewrite your application, but also Kubernetes resources and manifest as well. And then whenever I talked about this kind of topic, a lot of people actually ask me, hey, Dan, I heard KEDA and Knative, very similar name, pretty confused. And then what is the big difference between two projects? Just like Apache Pulsar and Apache Kafka. So it's pretty much similar, But here's some bullet point. I'm not going to go through every single detail, but the KEDA, you don't need to change any existing Kubernetes deployment and batch job, just standard way. You just create the scale job and then point to existing one, and it will be scaled out. That's it. That's why KEDA is super simple, and then people really like that. However, Knative, you need to create a new YAML file to specify the Knative services. Once you deploy the Knative services, that will be scaled down and up and down, just like Amazon Lambda, which means another burden. This is more like a developer's job right now, because once you develop application, you need to deploy this application to Kubernetes as a just normal pod. But however, you're going to deploy this one to serverless on the Kubernetes. This is you needed to rewrite or recreate the Knative service as well. And then KEDA, just watching, not watching, is technically pull some scrap metric data from Kafka cluster or Prometheus, and then just keep looking and when is a perfect time to scale out the application. That's why KEDA said we got a pull model, and then Knative has own autoscaler, not using the HPA on Kubernetes. That's why Knative just directly influenced to existing application like a pussy model. And then, so this is just some kind of stuff. And then I'm going to showcase more detail in the demo. So today I'm going to showcase 4 different demos. And then, so each case we're going to keep redesign the auto-scaling architecture for Java application, how to make it better, better, better. And then lastly, we're going to make it awesome. So the first use case, the application with some very simple. We have one application. I'm going to use Quarkus, of course, and then, but yeah, I have many different applications like Node.js and Spring Boot, Quarkus, even Python. But one of the reasons why I need to use Quarkus today, so you will understand at the end of the demo. So this is a one Quarkus application, and then one Kafka cluster, and then I'm going to create a new Kafka the messaging here. So let's get into demo environment. So here is my Kubernetes environment. This is actually Red Hat Developer Sandbox. When you go to developers at redhat.com page, you can sign in for free, and then we can give you Kubernetes cluster for 30 days. And then after 30 days, you're going to re-sign it, and we're going to give you once again unlimited. So it's 30 days. It's a limitation, but it's technically not limited. I also using this Kubernetes cluster. And then, so I already installed using operator. This is my Kafka cluster, like a Zookeeper, etc. And then here is my application. Is actually Quarkus theme. I have 2 projects here, and then the simple, very very simple. It's a Quarkus project, and this is a raised version. So here is a 2.16.4. So Quarkus community actually we release a new minor version every other week. It's almost 2 weeks. Super fast to change that. And then we gonna release Quarkus 3 in the middle of April. There are many great features coming out. For example, the virtual thread, the project room integrated Quarkus as well. So you can easily use the project room to create a virtual thread on top of the Quarkus. So this example is pretty simple. So one of the reasons I using Quarkus is for reactive programming. Is I've been doing a Spring integration, integrated Kafka. I need to use a Spring integration, Spring Cloud, and sometimes Spring function. Need to Kafka template create something like that, but you don't need to do that anything anymore with the Quarkus. You just need one single annotation incoming and your topic name. That's it. And then Quarkus automatically just parsing your incoming topic message on your Java method using JSON format. You can set it up like outgoing, which is you can processing your messaging. You can set it a channel, things like that. So anyway, it's a very simple Java method, and then I just consume the event message from my topic, which is a Kafka cluster, and then just print out. So that's it. That's very simple. And then, but this is not reactive programming class. It's more like auto scaling stuff. And then I'm gonna try to. This is my project. I'm gonna make it sure I'm the right place here. So here's the Kafka HPA, which is my project here. Kafka. Oh, this is Knative. Okay, I'm gonna change that. The Kafka HPA. I also create the Kafka cluster here. So back to the here, I'm gonna deploy my application. You could use Maven plugin, command line, or Gradle, and I prefer using Quarkus CLI because it's pretty simple and then provide auto completion feature, and then it's really easy to, you don't need to remember any argument parameter on your Maven and Gradle stuff. And then when I build this application, it automatically containerizes image and deploy to remote Kubernetes cluster. So how it works, when I go back to my project and then go to application property, and then there are a few compilation, this is a Kafka stuff. Where is my Kafka Bootstrap server here? This is a literally Kubernetes service name. If you use the external Kafka cluster from out there, you can just put in your fully qualified domain name. And then here's a serialized, deserialized stuff. And then I'm going to deploy the OpenShift, and then you can set it up OpenShift, and you can set it up Kubernetes. And we're gonna set it up Knative, and then it automatically generates YAML file because during the build, and then it automatically generates like a faster and then Kubernetes YAML file. For example, here is the OpenShift YAML because I set it OpenShift target environment, which I have like some resources like a deployment config, and then like a service here, and then image stream, and then it's all about just automatically generated. Also, when I create a Docker image, Quarkus project automatically generate Docker file here. It's automatically detect this Docker file and then create a Docker image. So it's pretty simple. You don't need to write Docker file and YAML file using Docker CLI, kubectl. You just need to use Maven or Gradle or Quarkus CLI. Pretty simple. And that's the reason why I'm going to try to use Quarkus for more developer experience. And now I have a Quarkus application here. And then when you go to view logs, and now I can, let me try to a little bit bigger. And now you can see the race project and a few Kafka client, Kubernetes, and a extension, which is a Maven dependency. And then I'm going to try, when you go back to here, and then you can see the application, and you can see the arrow up and down, which means I can scale up and down manually. It's not auto scaling, but it just deploy one application. I'm going to make it auto scale using you can use a kubectl, or I'm going to set my deployment min-max 110, and the CPU utilization is 70%. It's a more realistic thing. And then now you can see auto scale and set it up here. So I'm ready to make it auto scale. This is not event driven. I just what I wanted to showcase this first use case. This is just a general thing when we talked about first slide, the architecture. And then the Kafka cluster is luckily they already have own the performance script here. So inside the Kafka container, they actually have a Kafka project performance test bash script. So I don't need to some external performance tool. Kafka already provide this kind of stuff, beauty of a thing. I love that. So this, I'm gonna run this bash script with some parameter here. My topic name is my-topic. I'm gonna generate the 1 million, the dummy record in every 1 second here, and then I'm gonna run like a 5 different pod at the same time, so make it a heavy workload here. So I'm just copy, and then you can using like a kubectl command line, and then this sandbox, one of the beauty is to provide the GUI, and I just create a job here. And then you can see that new job just created, and then go to resources, and then it's a 5 pod just created. And then when you go to logs, you can see the new dummy code will be generated every single second in a 5 pod at the same time. And then when I check it in my application, and then go to view logs, and then my Quarkus application is super crazy busy to consume this 5 million data from Kafka cluster. And then, but when I go back to my application, the HPA here, and then you can see that so target is 70%, but the currently is 0%. What the hell is that? Because the HPA keep monitoring the CPU realization, even if Quarkus is crazy busy, but the CPU realization it takes some time to gather that actual number. So that's why event-driven is to keep coming millions data from Kafka or some other external services. But in Kubernetes standpoint, I need to take some time to figure it out. So in the meantime, your application keep slowing and then got some latency find out. So I'm gonna leave this application because it takes some time, couple of minutes to scale out. In the meantime, I'm gonna go back to slide where and then go to next use case 2. I'm gonna redesign this some not good architecture. I'm gonna put in the KEDA right now. So pretty much simple. So previously you have 2 boxes here. Now you have 3 boxes, and the one is KEDA. As you can see, KEDA keep gathering your metric data from Kafka, just like I said, pull, and then just ask to your application directly. Okay, now it's time to scale. Pretty simple. And then how do I do that? I just need to deploy application first, and then just create the scaled object. That's what I needed to do. And then let's go to demo environment and switch my project here, Kafka-KEDA project. And then just Kafka, no application. And then I already created some using deployment config here. So I just created deployment, and then here's just bootstrap here. So my Kafka cluster, and then here's my container registry. I'm gonna just try to showcase different way how to deploy application with different practice. And I just deploy application, which is the same Quarkus. So just deploy it and then go to view logs. Make sure I'm gonna using the same version 264 and the same Maven dependency, because this is a performance testing. So I needed to make sure I'm going to use the same application for the that cases. So now you can see that it's still up and down manually. And now I'm going to go back to create scaled object. As you can see here, the targeting deployment name is Quarkus-EDA demo, which is this deployment name. So I'm going to keep monitoring this one. And then what is my trigger to autoscaling, which is Kafka cluster. So now I'll just copy and then create a new resources here, and then go back to here. And then as I said, so scale object automatically create the HPA here. So now I don't need to create the HPA just like a command line. So KEDA automatically create HPA for your application. And then the application, as you can see, the auto-scaled enabled. And then I'm going to try to using the job, batch job, the Kafka performance batch job, and then back to here. Now let's take a moment how fastly this application scale out. So the performance, the batch job is already 5 created, and then once it just generate the random record, and then now you can see the pod is auto scale already 4. So pretty much faster. This is a really fitting the event-driven application. Now we have a 4 pod here, and then let's try to go back to the horizontal HPA stuff. How many pod is literally scaled out? So now we have a 2, and then the batch is already dropped on, but still 2 Quarkus pod is pretty much busy to process the 5 million data. And I go to horizontal HPA compilation. Now you can see so 70%, 69%. That's why we have only 2. It probably exceed like 85%, something like that. That's why it scaled out 2. And then that's it. and the HPS still takes some time gather CPU utilization number. So this is a pretty slow to scale out. However, when I go to KEDA, and now you can see the application already scaled up 10. So just min max fastly. So that's why the KEDA is pretty much good for auto scaling, even not serverless. That's the one of the reason why KEDA really good at scaling your application. And I'm gonna go back to slide show, and then moving to the next use cases. We're gonna another chance to redesign for serverless today. So serverless is based on event-driven application because the serverless application is scaled down to 0, just like hibernated and idle. And then once you give some event, and then the application just scale out, like just on idle. And then we have a little bit complicated the architecture here. Now you have a Knative. Knative actually not gonna monitor Kafka directly. However, Knative project they own infrastructure for eventing, which is Knative eventing. So as you can see, Knative eventing actually consume messaging, event messaging from Kafka cluster, and then that event messaging sending out to application directly like some kind of bridge liaison. And then Knative keep monitoring application itself rather than Kafka cluster. And then just ask them, yeah, yes, you need to scale out right now. That's why we can say the pussy model. So this is pretty much complicated. And then, but one big challenge for Knative is just scale to 1 rather than 1,000. So let me show that back to the demo environment. And I'm going to switch to Kafka Knative project. Once again, there's only topic. And then I'm going to go to switch by another project here. So one thing, the application standpoint and Java application standpoint, you might need to rewrite your application to consume cloud events. So reactive programming and then more event-driven application with the cloud event, you need to rewrite them. So the reason why, so reactive programming, some language or some people prefer to use JSON format to generate and consume, produce your event messaging. However, the JSON format is not only way to consume, produce your event messaging. Sometimes you're going to use the protobuf or the binary itself. So, and then multiple program language needed to communicate with the event-driven architecture with a different event messaging format. How do you do that? That's why traditionally you have like a messaging queue or some kind of integration platform. But that's not a cloud native way. So that's why cloud event project just came out. So whenever you use any kind of format and then wrapping cloud event, and then you can easily just communicate with across multiple the event messaging platforms. So I not gonna try to rewrite because this is only one single line to print out. But if you add some more business logic, you need to rewrite the application itself to deploy Knative. And also, when I go to application property, and then I just set it up the same thing, but one different thing here is the target is Knative. Previously, we set it up OpenShift. So we did that. Previously, OpenShift YAML file automatically generate, but now the Knative YAML file automatically generate. So let's go to my terminal window. I'm gonna try to change my project Knative. And then I'm gonna try to build my application once again. And then when I go back to my project, and then here's the Kafka source. This is a Kafka source, just like our presentation architecture. Here's a Kafka source. This is literally consuming your Kafka metric and sending to your application based on Knative eventing. So time's up. All right. So let's go back to here, and then so change my project Knative. Once we deploy this one, I'm gonna create to Kafka source. It will attach my application to process and the metric data from Kafka cluster to my Quarkus application. So that's why I don't have any kind of the application property around the Knative source, Kafka source. Network issue, maybe sometimes it takes some time. You could actually deploy application as a Quarkus native executable based on running on GraalVM. It's pretty much faster than the JVM stuff. And then Quarkus actually using fast jar rather than a thin jar or uber jar because the Quarkus framework override Java class loader, which allows Quarkus already know where the class path and the relevant libraries. So that's why it's a little bit startup time and then like a response time rather than thin jar or uber jar. That's why we call say fast jar. So that's why when you go to target directory, you cannot see the runnable jar right away. And then under the Quarkus app, you can see the run jar here. But you can also create the Uber jar or legacy jar just right on the target directory because some of the platform they only allows you existing the job file just on the target directory rather than two-level layer. Okay, and I'm just needed to Kafka source and then my application here. Knative. Oh. Is that I'm the same project? Knative, Kafka Knative. Let's try to. Oh, I didn't forget change my project directory. Let me try to change it. Okay, and then I'm gonna try to build once. Oh, but for that I need to delete it one because when you deploy the Knative, this showing a little bit different. This is just literally just normal application. So I'm gonna delete my existing one, and then let's try to make a cleanup here. So my build configuration, and then I'm gonna try to delete the image as well. Because it's gonna be conflict when I deploy serverless application. Alrighty, and then back to terminal, and once again, okay. So I forgot to change my working directory, so because it's deployed the existing one, but now I change it another project, which as I show you the EDA-Knative demo, and then it allows me deploy my application as Knative. It's during the this one I'm going to using actually OpenJDK 17 right now, and then go to target directory and then Kubernetes directory. Now you can see the Knative YAML and JSON file automatically generate rather than like a Kubernetes YAML. And then now you can see just example, Knative service automatically generate. This is one of the actually job for developer or some architect to write this YAML file, but as long as you just using Quarkus and it automatically generate, and then here is the image. Image is actually Quarkus automatically generate container image and then push it into targeted image registry. Today I'm going to use integrate container registry inside the developer sandbox. However, you can set it up like an external container registry like a Docker Hub or Google container registry or your company private container registry as well, and then it automatically replace that image here as well. So back to the console, and still working on that. And then, okay, just build success. Back to the application. Now you can see a little bit different. It's a Knative services. This is a different icon. And then back to here, I need to create to Kafka source. And it automatically attach to my application here. So I'm now ready, and then in the meantime, you need to take some time because this is a serverless application. Without any incoming traffic, this application power will be scaled down to zero next 30 seconds because 30 seconds is the default time scaled down to zero. But you can change it like a 5 minute, 10 minute, and then whatever you need. And then we give it some moment. In the meantime, let's try to really fun stuff. Because you have many applications at the same time, I'm gonna change it to make sure this application actually Quarkus. And then you can see Quarkus in the meantime, it will scale to down zero in a second. And once we scale down to zero, and then now the application is terminating, as you can see here, terminating, and they give us some a few more seconds. The same job, the Kafka producer performance test with the 5 million data every single second. And then once it scale down to zero, no pod anymore. And I'm gonna just run that batch job once again. And then we're gonna see how fastly it scale up from zero idle, just like a serverless. So now it's scaled down to zero, just like Amazon Lambda. And then I'm gonna just create my Kafka batch job here. And then you can see the Kafka batch job create, and then it automatically generate the random dummy record, and then every single second. And then as you can see, the application automatically start up, just like a serverless. And then as you can go to here, the same version. Here the Quarkus 2.16.4, and then you see that already more than 4,000 lines, which is almost 4,000 dummy record already processing by Quarkus. However, it's compared to KEDA, even if this is serverless application, but compared to KEDA, KEDA is in and after maybe 20 and 30 seconds, it's automatically scale out to 10, the maximize. However, this is scale 1, and then it's just the end of the journey. And then not going to scale out to 10. It's a one part, pretty much busy and crazy for the next 10 minutes, something like that. And then, so that's why a lot of people, some hard time to decide which one I need to go. Can I use the KEDA or Knative for event-driven for application regardless of serverless? Always you need to pick one of them. And then that is a big challenge for me and many other people like a developer and architect. But luckily, so we got a really good sandbox project today. That's exactly I wanted to talk about today. So I really want to event-driven, but not only general part, but also serverless. How do I do that? So there are sandbox project. It's literally integrate KEDA and Knative project today. So KEDA actually monitor and scale out the Knative eventing infrastructure. For example, Kafka source and then like a Reddit streams and then Reddit MQ, things like and AWS SQS, things like that. And then so this is maybe pretty much easier to understand for you guys. So it really complicated architecture right now, but the point is KEDA keep scrapping metric data from Kafka. And now KEDA not gonna scale out to directly application. Instead, they ask Knative eventing. So previously, there's one Knative eventing process. Now it scale out multiple process, which means it's a parallelly you can working, just like a one physical thread and a multiple virtual thread. So it's pretty much faster processing incoming data, as well as in Knative autoscale the application itself. So it's a multiple the multiplies the capability in the end. So let's go back to last demo stuff here. And then in the meantime, when I go back to HPA, just want to take a look at that. It's just go back to 1 because it's already done, and it just scaled down 1. And then what about the KEDA? It scaled down to 0 because I was I mentioned that, yeah, time zone again. So I have 10 minutes. So 10 minutes left. So the demo application scaled down to 0, just KEDA, just is HPA scaled down to 1, just like a first demo cases, and then now KEDA intervene, okay, it's down to 0. So two combination, which is really cool. But it still a little bit takes some time. And then Knative, we just give some heavy workload today, so it's maybe take some time scale down to 0 in the end. And then here's the last project, Kafka, KEDA, Knative. So just deploy that and just try to make sure change my project first. KEDA and Knative. Is it right? Okay. I'm gonna change my application. Also, I need to change my application to target environment. So this is a namespace. I'm gonna change the namespace from Kafka, KEDA, Knative. And also, I need to, one of the good thing of the Quarkus, you can actually to set it up the specifically Knative configuration on your application side in programmatically. So as you can see here is the scale 0 to 10 and then so target and then something like that. Without that, if your application framework, and not even Java, but also any kind of language platform, not provide this kind of feature, you need to set it up this kind of thing on your YAML file. So, and then this kind of automatically generate YAML file. And then I just save a file and then back to here. Let's try to build once again. And then I'm going to try to once again create the Kafka source. But in this case, I can add a few more computation around KEDA here. So as you can see, KEDA annotation, you can actually edit it based on that sandbox project. So as long as you add the KEDA configuration in my this YAML file and it integrate my Knative project and the KEDA project for the event-driven autoscaling. This is not only Java application, by the way. This is any kind of application as long as you're going to deploy that application on top of the Kubernetes. So, and then the other stuff, and then I was using Quarkus for reactive programming as well as like a Knative configuration on application side. So once I deploy, and then I'm gonna attach that kind of stuff. So this is a last demo. I have a few more minutes, so hopefully gonna be not broken. Yeah, I didn't pray the demo god today early morning, but yeah, it should be okay. Yeah, yeah. So sometimes so one of my stuff is to talk about Kubernetes native Java in a lot of international developer conference. Sometimes I'm going to showcase how fastly you create the Quarkus native image, and then how fastly it can start up, like a 10 millisecond to start up, compared to Spring Boot, and then how small memory size and then image size, and then sometimes the very bad network bandwidth, it takes 5 minutes, even if an application start up just 10 milliseconds. And then everybody don't believe that. Yeah, we need to spend 5 minutes to run 10 milliseconds. That's ridiculous. That's why I always need to check some network bandwidth in campus Wi-Fi. But today, I'm just using hotel Wi-Fi. So finger crossed. Okay, so give us a moment. And then, as you can see, you can actually using Docker and Podman to containerize the application. So let's go back to application and just give us a moment to look at the Docker file automatically generate. So here is the Docker file for JVM. So you're going to use OpenJDK 17 because when I generate this project from scratch, my JVM JDK is based on 17. That's why it's automatically generate OpenJDK 17. If you're still using 11, it automatically set up 11. But 19, we not support yet, but we're gonna do that soon. And my 20 just came out, and then we're gonna catch up that today. And then the legacy jar, as I said, so just JVM, the fast jar, as you can see, This is from here, the Quarkus dash app, one more layer under the target. However, the legacy jar is literally just under the target directory. So in this case, this is using the docker.legacy jar, and then this is a native compilation. That's why you can just run up a file under the target directory. And then this is a micro. You just need to more like a smaller image. So Quarkus actually we provide based on KEDA container registry provides the Quarkus micro-based images, pretty much thin and then small thing. Okay, just done. And then back to the application. I have a Quarkus here. And then I just create to Kafka source. And hopefully, attach to my application here. Okay, now my application here. And once this application scaled down to 0, and I'm going to run my batch job once here. So my Kafka topic. And then let's try to add the label once again to make sure you can actually set it up like a Spring Boot or Quarkus or a Python, whatever you need. So make sure differentiate it. And then my application is gone. Okay. So now I'm going to create the performance batch job here. And then back to here, the pod is just create a file. And then my application gonna be start right away to consume the application. And then once you consume the application, now you can see so right away edge start and the right away scale to 4, and then it pretty much dynamically up and down based on the multi-process in the middle of a Kafka source and Knative and KEDA integration. So as you saw the KEDA project, it takes like a few seconds to start up and 1 and then at the literally 4 and then 10. But this is just the first 4, not going to go to 10 right away because it's still monitoring. Okay, we still have a multiple process to consume your event messaging. We take some still window to process it. And then after that, we can scale out to 8 or back to 6. It's really real-time processing your event-driven for serverless application. So I'm going to go back to my slide deck and then just wrap it up and then back to my demo environment to just revisit the Knative KEDA stuff. Okay, so today I'm going to just using Kafka source. And then there are more sourcing here. AWS SQS and the Redis streaming and the RabbitMQ broker. But today we still needed to ask KEDA, yeah, you need to check it out. Kafka source, like Knative eventing infrastructure. And then Knative eventing infrastructure is a middleman that actually asks to our application itself, Knative service. But we are working on the new feature, so KEDA automatically and directly asks Knative service rather than like a transit to Knative eventing. In that case, it's pretty much faster than current status. And then just a few bullet point takeaway. So still people a little bit confuse KEDA versus Knative. KEDA is based on very simple using standard Kubernetes resources. And then it's a pool model. However, Knative own autoscaler and a pushy model. And then so KEDA can autoscales Knative eventing infrastructure for now. And then in the end, it will autoscale Knative services directly. We are really hard working on that in the targeting in end of this year. And then the last thing is you can visit it, this GitHub repository, Knative Sandbox project. You can replicate this kind of stuff. And you can come to my GitHub repository, github.com Daniel030. You can find all kind of stuff. And actually, this is my YouTube channel. And I uploaded more than 100 of the tutorial demo around the Quarkus, Kubernetes, and the serverless, and the GitOps pipeline, and Argo CD, and the Spring Boot, and things like that. And this for use case also, I put into my channel. So in after session, maybe you can just revisit and feel free subscribe as well. Here's a QR code and then pin the URL. Yeah, and then that's what I need. And then last thing is here's it. If you're really interested in Quarkus stuff, and then you can go to here quarkus.io and the Julep chat, and then we have a GitHub repository, Twitter. You can just scan this QR code, and you can find all information. And then you can reach out to me anytime, and I will be there. Now let's go back to here. And now you can see, and the job is done, and then the application scaled to 7, and then the dark green, dark blue means it's scaled down, and the up and down is pretty much flexibly and dynamically rather than using only Knative or KEDA. Thanks for joining today, and then hope you enjoy the rest of this conference. Thank you.